Hello everyone, welcome. This is Dr. Anjit, your pathology faculty at Amalgam PG. And today we are going to see an interesting topic of pedigree analysis. I'm sure you must have had difficulties in solving a pedigree at least in some point of time. You must have had a pedigree image in genetics and they'll ask you what type of inheritance is it? Is it dominant, recessive, autosomal or X-linked or mitochondrial, right? Definitely you must have had some difficulty in solving them. Now in this video, I can assure you, you can solve a pedigree within 10 seconds. If you're not able to solve the pedigree in 10 seconds, with keeping in mind whatever I'm going to say, the pedigree is wrong, not you are wrong. I want you to be extremely confident in thinking that the pedigree is wrong and not you are wrong, right? So on that note, let's keep our ambitions high and I'm sure you'll be able to solve this pedigree. I'm going to keep this video very short, maybe to 10-15 minutes. 10 minutes you read this video. Make sure you keep a note of this, write these down, the rules of pedigree solving, what I'm going to say. Apply them in any question which comes to you in future regarding pedigree analysis. It has to become correct. Because whatever rules I'm going to say is going to date back to Gregor Mendel. Mendel laid down these rules for the Mendelian inheritance. That's your autosomal dominant recessive and it can never ever go wrong, right? So if the pedigree you're not able to solve in 10 seconds, the pedigree is wrong and you are right? So let's go ahead. And what we are going to cover in genetics in Amalgam is these are few things which I intend to cover in the coming videos as well. First is going to be the few basics of genetics and regarding pedigree analysis. And we'll see a quick look about Mendelian pattern of inheritance, which is autosomal dominant recessive, and quick naming about non-Mendelian, which includes your imprinting disorder, mosaics, chromosomal disorder. These are non-Mendelian. So little bit information about that, mitochondrial, little bit information about that, and few things about your Down syndrome, your Pateau syndrome and everything, fine. So I'll divide the genetics chapter into 2-3 videos so that it'll be easy for you to go through whenever you require it, fine. So let's see. To understand a pedigree analysis, I need to know how the symbols look. Right? So few basic information about symbols used in pedigree. So with that help, you'll be able to, if the question comes on what is this symbol or what does it mean, you can solve that as well, right? I'm going to go with very basic information here. I am sure you know this for a women and for a men, right? So I'm not going to talk about this. So when you have a women and a men linked with one line, it's mating or marriage if you want to use their traditional terminology, right? So if it's single line, I'm going to call it a mating. And if it's double line, it's mating or a marriage between relatives. We call them consanguineous marriage. Con means union, sanguineous means blood. So they are blood related individuals who are giving birth to a kid. That's consanguineous marriage. I'm sure you must have learned about consanguinity in the past. So that's what it means. I'm going to draw two lines in between a man and a woman. Then I'm going to call it a consanguineous marriage. Fine. So let's see here, what you must have generally seen in the pedigree is, you'll have a father and mother, a line, and below that you'll have kids, offsprings. Generally when we draw kids, what I'll use to draw is, let's assume I'm going to draw like this. I'll draw like this and maybe put a girl or a boy, right? Generally it'll be single lines. That's how we draw generally about the offsprings or the kids in single. So if you have something, if you look at this image, it is perfect, the offsprings, but once they become offsprings, they are bifurcated, right? They become like two things. So when you have two bifurcation in offsprings, these are twins for twin pregnancies. And if you closely look, there are two things here, both are different. When you have a bifurcation which is not connected, the first one, these two are not connected, right? These are dizygotic twins. They are not connected genetically. When you look at this, both these things are connected by a line, which means they are connected genetically. They are monozygotic twins or identical twins. Keep in mind, that is not conjoined twins. They are connected genetically, they are monozygotic twins, right? And few more informations. This might be to the next step, like if you're writing an INICT exam, little bit of an higher information. If you have a tiny dot, that's an abortion. If you have a diamond, that's an unknown gender. It could be a fetus, because in India, as per the act, I cannot reveal the gender of the fetus in the intrauterine life, right? So that should be a fetus most likely. And if you have anyone in brackets, be it male or a female, if you have them in brackets, it means the kid is adopted. It's coming from some other different family. That's the symbol for adoption, fine? And I'm sure these three you definitely know. Completely shaded, the affected or the diseased individual. Half shaded or you have a dot, this means your carrier state or your trait state, fine? You must have known about carrier. Must have read about sickle cell anemia trait. beta thalassemia trait, that's the carrier state. And recessive inheritance will have carrier state, right? So this is the first basic premise. Because once I know these symbols, pedigree solving is very simple. This is my first thing. The second thing what I'm going to go is to the rules of pedigree. I have like two rules. A single rule and a simple flowchart. I want you to remember that flowchart and I want you to read the flowchart the day before the exam. If a question comes on pedigree, solve it in 10 seconds and move to the next. You will be correct. Fine. So see here, I'm having rules to solve a pedigree. This is my first rule. So for any pedigree given to you, I want you to always look for mitochondrial inheritance. This should be the first and the cardinal rule. Do not miss this. If you miss this, you might go wrong, right? So to prove something is mitochondrial, see, mitochondrial is maternal. Your mitochondria, my mitochondria, every human being's mitochondria comes only from the mother. So if the mother is affected, all the 100% of the offsprings or children will be affected. The dad doesn't contribute about to mitochondria to any person in this world. So if the dad is affected, none of the kids will be affected. That's classical for mitochondrial inheritance. I will show you pedigrees and believe me, you're going to diagnose them, not me. Fine. Next, I have the flowcharts. So this is the first rule. For any pedigree which comes to you, first rule out mitochondria. See if mom is affected, that's a round person completely shaded, affected, all the kids should be affected. Dad affected, the square not affected, none should be affected, right? So that's for mitochondrial. Next, come to flowchart. This is the most simplest flowchart you can have for any pedigree, right? We'll divide them. Don't think it's very cluttered and difficult. It's very, very simple. The first question I'm going to ask for any pedigree is, I'm going to ask if multiple generations are affected or if all the generations are affected. We'll keep like that. If you have all the generation affected. So a little bit of information of what means a generation. You and your cousins form a generation. Not just you and your brother or sister, you and your cousins. Your parents and their cousins form a generation. Your grandparents form a generation, right? So that's what I mean by generation. When I say all the generations are affected, doesn't mean that every individual should be affected. One person in one generation affected, I call them that generation is affected. That's more than enough, right? I'll show you pedigrees and you can easily solve them, fine? If all the generations are not affected, which means I have one generation where I don't have the disease, I'm going to think of a recessive disorder. If it is a recessive disorder, it has to be only two things, autosomal or X-linked, right? If it is an autosomal recessive disorder, both men and women will be affected. That's the question next. All affected are males or not? If the answer to that is no, right? My answer is autosomal recessive, which means autosomal recessive will not have a gender bias. Both men and women affected. If only male are affected, X-linked recessive. You must have read about this, right? Hemophilia affects only men, right? G6PD deficiency affects only men because X-linked disorder. So X-linked recessive affects only men, autosomal recessive affects both of them, right? So we'll look at this part of the flowchart alone. All the generations affected, answer is no, recessive. Only men affected, X-linked recessive. Both men and women affected, autosomal recessive. Simple, very simple, fair enough. This will take less than 10 seconds, right? We'll look at the other part. Because the other part might be a bit complicated, but still, my first part is done with. If all the generations are affected, I'm repeating, at least one person in every generation should be affected to call it all generations affected. In that case, the next questions I'm going to look if there's a male-to-male transmission. So what do I mean by that is a dad transferring the disease to a son. And I'll give you an example. Let's assume I am having an X-linked dominant disorder. Fine. So which means my X chromosome is muted. Me being a male, I'll have one X and one Y chromosome, right? That's my genotype. So if I have to transfer the disease to my son, I cannot give X chromosome to my son. Because if I give X chromosome to a zygote, women have only two X. That X comes, my X goes, it becomes a daughter. On the other hand, if I have to give birth to a son, I have to give Y chromosome. In that case, X-linked disorder will not be transmitted. Got it? I'll rephrase it, I'll repeat it again. Having an X-linked dominant disorder. My X chromosome is abnormal. To give birth to a kid, male child, I have to give my Y chromosome. Then only it will become a male child. If I give my affected X chromosome, it becomes a female child, right? It becomes a daughter. So if I have to have a son, my transmission should not happen. So if there is no male to male transmission, I am going to think of an X-linked dominant disorder. First step. If we have a dad to son or a male to male transmission, I'm going to think of an autosomal dominant disorder. Obviously, because autosomal does not involve your X or Y chromosome, so I don't have a problem in that. Fine. Okay. So now if I know that it's an X-linked dominant disorder for sure, so what I'm going to look at next, fine? If it is an X-linked dominant disorder, you're going to see, are all the daughters of the affected male affected? Same example, I have an X chromosome which is mutated. If I have to give birth to a daughter, should I give the only X chromosome which is mutated? Yes. So in that scenario, will all the daughters have the disease? Obviously, right? So if I have an X-linked dominant disorder, and if all, it should be 100%. Every single daughter born to an affected dad will be affected, then it's X-linked dominant. If the answer is no, it is autosomal dominant, right? These are very simple rules. If you're a bit confused in this, we will apply them. It becomes extremely simple for you, fine? I'll repeat the dominant pedigree again. All generation affected, yes, dominant. Dad to son transmission seen or not seen. If it is not seen, X-linked dominant. Seen, maybe autosomal dominant. To prove it is X-linked dominant, there is dad affected, all the daughters or female childs are affected, then it is an X-linked dominant disorder. Clear? Let's go and apply it. 10 seconds. Maybe the first time when you apply might be a bit difficult. The rest of them will be really less than 10 seconds. Let's look at this. I want to talk about few things here. First, I want you to know what does generation mean. This is one generation. This is second generation. This is third generation. This is fourth generation, right? So when you see all generations are affected or not, please don't ignore this. Generally, people ignore the first one. So generation includes everything, right? So all these are generations for me. You have to include everything there to call something as generations, right? So here, this generation, one person affected, yes. Affected, 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 affected. All the generation are affected, right? So I'm going to think of a dominant disorder. What is the next question? Dad to son transmission. Dad affected, son's not affected, right? Dad affected, son's not affected. So there is no dad to son transmission. So I am going to think of an X-linked dominant disorder. There's no transmission, right? It's not complete. Don't write as X-linked dominant. You have to ask the next question. If the dad is affected, are all 100% daughters affected? Dad affected? Oh no. One daughter is not affected, right? Which means all 100% of daughters are not affected, which means it is not X-linked dominant. It goes to autosomal dominant pedigree, right? So if you have a doubt, go back to the flowchart again, have a look. All generations are affected here. Dominant, male to dad to son transmission not present, most likely X-linked dominant. But when dad is affected, not 100% of the daughters affected, becomes autosomal dominant, right? This is the maximal complicated pedigree you can have. It is autosomal dominant inheritance, right? It's very simple here, fine? Again, if you have a doubt, go back, or anytime you can contact us in the Amalgam Telegram group. I'll be more than happy to help you, fine? We'll go to the next thing. It will become 10 seconds. If you want, you can have a stopwatch. You can see the time used. See here, I have many generations. Are all generations affected? No, right? The first generation is not affected. So it is recessive. If it is recessive, only two possibilities. Both men and women affected here. Yes, female affected, male affected. Autosomal recessive. Right, just 10 seconds. It took less than 10 seconds. That's all. All generations affected? No. Recessive. If it is recessive, both are affected. So autosomal recessive. Next. All generations affected? No, not affected. Recessive? Yes. Only men affected? Yes. So it is an X-linked recessive disorder. Less than 10 seconds? Obviously it has to be. That's what conceptual reading means. Do not memorize. Right? So please go for a source where you have an authentic faculty teaching you the respective subject. If you have one faculty teaching all the subjects, you won't have the in-depth understanding. Unfortunately, you have to memorize it, right? This is how concepts are, and concepts will create you a long-term impact. You will clear any exam for that matter, fine? Next. I put this pedigree particularly in last so that we can see where you can see mistakes. All generations are affected? No. So most likely recessive? Yes. Both men and women affected? Yes. So you'll go for autosomal recessive, right? Wrong. Why I said it's wrong is When I use the rules of pedigree, I told you to apply. First rule is to rule out mitochondrial, right? Mom affected, all the kids are affected. Dad affected, none of the kids are affected. Again, mom affected, all the kids are affected. Is it mitochondrial? Yes, this is mitochondrial inheritance. Why I wanted you to make a mistake and then learn from it is you won't miss it. If you ignore the first rule, that is rule out mitochondrial, you might mistake this for an autosomal recessive pedigree. So please don't do that. So always the first rule is rule out mitochondrial inheritance. Then obviously you're going to see it's dominant or recessive. If it is recessive, gender, dominant, two more questions, that's all, fine. I hope it is simple and easy, right? So if you have any doubt at any point of time in understanding a pedigree or in understanding any subjects, please contact our Telegram group. We'll be more than happy to help, and we are going to create a dental revolution in terms of studies. Thank you for your time. See you soon in another video. Till then, bye-bye from Dr. Anjit. Bye-bye.